Here I have three dice, red, green, and blue. Okay, so the red die is fair. Okay, 1/6, 1/6, all of them 1/6. The green is loaded, so that 5 and 6 appear twice as many as the others. And blue is also loaded. One appears half as many as the others. Okay, so red die is fair. Green and blue are not fair, but their characteristics are a bit different. And then I have an urn in which I have one red, one green, two blue balls. So here you have an urn. Okay, let's show this. You have an urn in which you have um, how many blue? Okay, I have two blue balls and then one red and one green. This is your urn, and then you have, of course, the dice. One green, one red, and then one blue. Okay, so red is fair. This is fair. Okay, green is loaded. 5 and 6, 5 and 6 appears twice as many as the others, and with the blue, one appears half of the normal. Okay, so this is the situation. The question is, what is the expected value of the die outcome? So what I do is I pick a random ball out of this urn. So and whatever color comes out, I use the corresponding die. So if I pick the blue, one of the blue balls, I use the blue die. If the red ball comes, I roll the red die, and if the green ball comes out, I use the green die. The question is, what is the expected value of the die outcome? If it were a fair die, it would be 3.5, right? Because 1, 2, 3, 4, 5, 6, the midpoint is 3.5 if they are all equal probable. But now I do not know which die I'm going to use, but I know their individual distributions. So what does that mean? I know the distribution of the outcome conditioned on the outcome of the ball, the outcome of the error. Okay, I do not have the final outcome of the die outcome. I don't have that distribution, but I have the distribution of the die conditioned on whatever ball I pick. Okay, so what I have is this. We will define X as the die outcome. Okay, of course, it's in the set 1 through 6. And we will define another random variable y to represent the ball, the outcome of the urn. Okay, red, green, or blue, I'll represent them as 1, 2, and 3. So what we have is conditional distributions because we know the characteristics of the dice. Okay, the red is fair, all of them 1/6, and the green 5 and 6 each appear twice as many as the other. So 1 through 4, we have 1/8. 5 and 6, we have 2/8. Okay, twice as many as the others. And with respect to the blue one, 1 appears half as many as the others. So these all have 2/11. This one has 1/11. You see all PMFs add up to 1. So that's I have arranged them so that they are legitimate probability distributions. Okay. So I would like to compute expected value of X, but you see I do not have the distribution of X yet. So to compute the expected value of X, I use the law of total expectation. I condition that on Y and take this outer expectation. Okay. Because you see, I have the distribution of X given Y equals 1. Therefore, I can compute from this distribution X given Y equals 1. And here I have the distribution of X given Y equals 2. So I can actually compute expected value of X given Y equals 2. And similarly from this, I can compute expected value of X given Y equals 3 from this distribution. Okay. And each of these I will weight with respect to the distribution of y, because if you remember, this outer distribution, as I said, is distribution with is an expectation with respect to y. So each of these I'm going to weight according to the PMF of y at these values. Okay, so therefore this is sum from 1 to 3, expected value of x given y equals k being 1, 2, or 3, weighted by the PMF value at k. Okay, if you write this in expanded form, here you have the expected value of x given y equals 1 as all of them divided by 6. Okay, and 1 over 6 times 1, 1 over 6 times 2, 1 over 6 times 3, and so on. And this here, expected value of x given y equals 2, that is 1 over 8 times 1, 1 over 8 times 2, 1 over 8 times 3, 1 over 8 times 4, and then 2 over 8 times 5, 2 over 8 times 6. And finally, you have expected value of x given y equals 3, okay? That is 1 over 11 times 1 times 2 over 11 times 2 times 3 times 4, etc. If you add them up, and of course here you are going to insert the PMF values of y at each k value, because if you remember, I have 2 blue, 1 red, and 1 green. So this has 1 over 2 probability, and these have 1 over 4. So the PMF of y here, this will be 1 over 4, this will be 1 over 4, and the red, this is red, this is green, and this here is blue, 2 over 4. If you add them all up, you get 329 over 88 as the expected value.